Hi everyone, in this video I want to show you a nifty little toy for solving linear systems, and it's called Cramers Rule. And the way it works is all about computing determinants and then just doing some divisions. Let's say we have a matrix equation AX equals B. These are the numbers that we're going to need to find. The determinant of A, and we're going to need the determinants of what I'll call A1 through AN. And these A1 through AN, they are just copies of A with the ith column replaced by that constant vector B. Once we have those values, the solution to the linear system is a piece of cake to compute. Because to get the solution value for any one of those variables, we're just going to take the ratio of the determinant of the corresponding modified matrix, AI, and divide it by the determinant of the original coefficient matrix. So let's see an example. So here's a linear system, and the matrix of coefficients looks like this. And the constant vector is this. And those three matrices, A1 through A3, look like these. And now we need to compute the determinants of each one of these matrices. Seems like it's going to be a lot, but these are pretty simple matrices, so I can use some of those tricks that I know about row operations and the fact that I can do cofactor expansion on any one of the rows or columns as long as I am mindful of the pluses and minuses checkerboard. It's really not too bad. So, for example, look at this first matrix, matrix A. Do you notice that if we did row 3 minus row 1, just a single row operation, we would end up with a triangular matrix? Just imagine doing that in your head. Row 3 minus row 1. The resultant row here is going to be 0, 0, 1. So our diagonal entries would be 1, 2, 1. So that means that the determinant would be 1 times 2 times 1. And since this kind of row operation doesn't affect the value of the determinant, I know that that's going to be the determinant of our matrix as well. So it'll be 2. For these matrices, A2 and A3, they each have a row that's got 2 zeros in it. So I can do cofactor expansion along that second row, and I'll be able to get the determinant right away. So the determinant of A2 is going to be, let's see, I have to go through that checkerboard in my mind. Plus, minus, plus, and then this is going to be below a plus, so it'll be a minus. So I'm going to have negative 1 times the determinant of what I get when I cross out that row and column. So that'll be 1 times 1 minus 2 times 1. That's negative 1. So altogether this is negative 1. And the determinant of A3 is, let's see, we have plus, minus, plus here. So all the diagonal entries correspond to pluses on that checkerboard matrix. So I'll have 2 times the determinant of the rest of this, which is 1 times 1 minus 2 times 1. So that'll be negative 1. So this is negative 2. Now this one, A1, I didn't see a shortcut for. That determinant is equal to 5. All right, so we have our 4 determinant values that we needed. So that tells me that x1 is going to be 5 over 2. x2 is going to be negative 1 over 2. And x3 is negative 2 over 2. So that's just negative 1. And that's it. That's Cramer's rule. Pretty cute, right? That's all for now.